So, what's the motivating policy question for this study? How might transit-oriented development and vehicle pricing policies change local commercial vehicle miles traveled and greenhouse gas emissions? For those of you who aren't familiar with transit-oriented development, this refers to development that supports expanded light rail and tries to encourage increased transit ridership, more walk and bike trips, and shorter auto trips due to better proximity of employment and housing. Okay, why is commercial vehicle travel important? Here we can see the share of total VMT, vehicle miles traveled, and greenhouse gas emissions in the U.S. for both light-duty vehicles and commercial vehicles from 2013 to 2040. And this is from the EIA projections for 2013 that were produced in 2013. So you can see here that we're making progress on light-duty vehicle VMT, however, and GHGs. However, the opposite is true for commercial vehicle travel. We're on an upward trajectory, and I think we're all interested in how we can change that trajectory. Okay, what do other studies say about what demand management measures might do to vehicle miles traveled and greenhouse gas emissions? Well, there really isn't actually a whole lot of research in this area. There is, the research that's been done on transit-oriented development does indicate that there's a correlation between, high-density cities and lower per capita greenhouse gas emission production. One study looked at about 100 metropolitan regions in the U.S., and there are a couple of other studies in Texas and one in Sydney, Australia, using slightly different methods. And then the next, distance-based pricing. So I don't know if you're all familiar, but there has been some talk in certain circles about replacing the gas tax with a VMT fee. That would be a fixed fee on every mile traveled by a vehicle. So, the literature generally acknowledges that this really should significantly reduce vehicle miles traveled and associated greenhouse gas emissions. There's less research that focuses specifically on commercial vehicle travel. So because of the interest in the VMT fee, there have been a number of pilot projects throughout the U.S., I think in about 14 states actually, looking at the behavioral effects of these fees and also the technology and institutional feasibility of these fees. And then in 2012, the GAO actually came out and recommended a VMT fee just on commercial vehicle travel. They felt that they were technologically and institutionally in a place where they might be able to implement it. Okay, so what are we doing? How do we address the question? So we simulate with the California travel demand model, transit-oriented development policies, and then a VMT fee. Now, this model was developed by Ultrans and researchers at the University of Calgary for the California Department of Transportation. It is the statewide travel demand model, the first version of it. So it's an advanced activity-based microsimulation model. It's the first such model applied at a large geographic region. In the past, it's been applied, those types of models have been applied to smaller cities and regions. And what's important for you all to know is that we have an explicit treatment of both personal and commercial vehicle travels in this model. So this is basically a schematic of the model. I'm not going to go into details here. You're welcome to discuss it with me after the session today. And this just basically shows the data used to develop this type of model. It used the California travel surveys developed in the early 2000s for the MPOs and the state. And just one way to think about simulation models, I know they feel like kind of a black box to a lot of people, but they basically use and integrate a lot of different data sets. And with the integration of those data sets, you can sometimes ask questions and evaluate the results that you couldn't really obtain for a single data set or a subset of one of these data sets. It's kind of, there's a synergy. Okay, so what's different about this study? Well, we're using a new type of local commercial travel model. It's tour-based, and this model was developed by our colleagues at the University of Calgary. So there has been a lot of research in tour-based models over the last decade, and they're just becoming kind of mature enough to be applied in a practical context. And this is one of the first cases of such an application. So these models better represent underlying mechanisms driving change in commercial vehicle travel due to public policies, investments, and plans that might alter travel distances, times, and costs experienced by commercial vehicle drivers. Okay, so now I'm going into the description of our scenarios that we simulated for the year 2035. So basically, the base case scenario, we assembled MPO forecasts as well as projects from their Metropolitan transportation plans, and we included those projects in our network. These were collected as of August 2011. And so it's important to remember here, these for the large part, are not the latest regional transportation plans or the SCSs of MPOs. Okay, so then we simulated a VMT fee by doubling the per mile operating cost. And here you can see a comparison between the base per mile fee and then the VMT policy per mile fee in the year 2035. Okay, this next slide shows the transit-oriented development scenario that we developed. So in 2035, we moved about 4 million people closer to transit in California. That was about 8.2% of the population in 2035. And we increased population density in the state by about 9.5%. So here, this just kind of describes how we moved people, these 4 million people. So the area, the small green circles are transit stations, passenger transit stations. This includes rail and light rail passenger transit. So the purple areas are areas 3 to 12 miles away from this transit service. And then the green areas around the station are 3 miles around a transit station. So we basically moved the growth from 2008 to 2035 from those purple areas and moved them into the green areas to see what would happen. And this is for the San Francisco Bay Area. It illustrates how we moved land uses. Okay, now we're looking at some of the results of our scenarios. So this one shows congestion, changing congestion for the AM peak. And at the top on the right, you can see the base case scenario. There's quite a bit of congestion in the LA area. And then you can compare that to the VMT fee scenario, again on the lower right. You can see that there's really a big reduction in congestion. So this is what happened. We've got here percentage change in local vehicle travel. And again, this is compared to the base case scenario. Basically what happens is that trucks are making more short trips. So the financial incentive or the financial penalty of the VMT fee is a disincentive, is actually an incentive for them to drive shorter distances, but the reduction in congestion allows them to take more direct routes and to take more trips within the same amount of time, if that makes sense. Right? Does that make sense? Hopefully I can show you this next slide here. Okay, so here, this is incremental 5-mile bins for local commercial vehicle travel. Oops, I moved ahead. There we go. There we go. This is for the VMT fee. So you can see the shift to the left. they're making more shorter trips. So they're able to have more direct routes due to reduction in congestion, and they're able to serve more people, make more stops in the same amount of time. Okay, this is a Todd scenario. You can see kind of relative to the VMT scenario, there's more of a modest reduction in congestion. And we see here that there's a reduction here, a slight reduction in VMT per trips, tours, trips in general, and VMT. So what's happening here is there's a closer proximity between origin and destination pairs. So, where they're going, the destinations they have to travel to are now closer. So this is illustrated here. You can see that the distribution of trips and VMT stays about, it's still the same pattern of distribution, but it's slightly lower. And that's due largely to the proximity of origin and destination for the trips. Okay, this just compares the magnitude of change for the VMT fee and the TOD. So it's not considerable reduction in emissions, in VMT, excuse me, or delay. It's a fair amount for both. So the TOD scenario appears to provide modest reduction in commercial vehicle travel due to closer proximity of origins and destinations. The VMT scenario has significant reductions in commercial vehicle travel due to dramatic congestion reduction and financial incentives to minimize distance traveled. So it may be that this is increasing local commercial vehicle productivity, excuse me, if that appears to be the case. An interesting question or next step is whether this increased productivity or potential increased productivity could offset the VMTs faced by the commercial vehicle industry. So that's it.
Thank you very much, Carolyn. A huge amount of information there, and I expect we'll get some questions, but very interesting. Let's see. I can do this. There we go. Okay. Okay, our third and last but not least discussive panelist here is Tom O'Brien. And Tom is, since I've known him, which is sort of very recently, he's in very high demand, at least is going to be presenting at just about every conference that I'm going to on this subject over the next several weeks and months. And he's going to be talking about the planning for freight management, urban freight and gateway strategies, including strategies for things like first and last mile. And I know there's a magic function key you can do for this, but anybody know what it is? F5. Yes. All right. Tom?
Thank you, Anthony. Today I'm going to be talking a little bit about some research that we did, we being the Metropolitan Transportation Center, which is a partnership of USC and Cal State Long Beach, where I'm based, looking at issues tied to urban freight management. That's to say, as Anthony mentioned, last mile delivery issues within urban cores, as well as those urban centers that serve as principal trade gateways, centers for ports, airports, border crossings, and intermodal connections. This is work that we did for the National Academy of Sciences Cooperative Freight Research Program. If you're not familiar with that, the cooperative research programs are designed to stimulate applied research that leads more rapidly to implementation on the ground. And what the National Academies was interested in was solutions and a scan of work that had been done globally on urban freight management strategies, and to examine the effectiveness of alternative strategies with a particular interest in their transferability in the US context. That was sort of the focus of our work. That report, that monograph, is done under Project 36.5, and it's in final review, so it will be available on the NCFRP website, hopefully within the next couple of weeks. It's work that as I mentioned, I did in conjunction with partners at Metropolitan, Jen Giuliano and Kevin Holliday, as well as Laetitia DeBlanc, who's with IFSTAR in Paris, which is a freight research center that's based there. The idea is that this topic is of critical importance because we have a lot of information from the engineering disciplines on optimization of routing, something that we might refer to as city logistics, truly the logistics arm, but we don't have a lot of good information on those strategies that address the complexity of governance issues within metropolitan areas, as well as the difficulties of bringing along industry for whom many of these strategies are designed. What we did, as I mentioned, we did an international scan. We looked at domestic and international literature, including the academic literature, journals, industry reports, consultant reports, unpublished papers, interviews. We came up with a principal list of 261 distinct references. About just under half of those are academic papers and scientific books. And we found sort of that there was a consensus developing about those projects that were the most useful, that were repeated most often in the literature. And so we focused our report actually on 63 different practices that also demonstrated positive results to look at their likelihood of transferability in the US context. Half of the practices actually come from North America. Many of them involve gateway strategies. The balance are from Europe and Asia, with the largest single group from Asia. We organized the strategies into three principal areas. The first being last mile strategies, which Anthony mentioned. Those are the ones that address local deliveries and pickups to or from urban businesses and residences. And this focus on residences is increasingly important because of the growth and the phenomenon of e-commerce and what it means for impacts within local communities, not just in commercial districts. And from what little we know from New York case studies, we surmise that about a third of urban truck traffic is pickup and delivery in any event, and that means problems with regard to complex routing, smaller delivery sizes, as was mentioned earlier, those deliveries occurring in peak periods when there's maximum interference with personal vehicle traffic, and as I mentioned, more home delivery. The goal of these last mile strategies is efficiency. There are very often positive environmental benefits that come from these strategies, but the focus, as I said, on these last mile strategies is largely efficiency in operations and delivery. So we separated those strategies from the ones that were specifically designed to have an environmental impact, whether it's reduction in noise, reduction in truck emissions, or incentives to use less polluting vehicles. And then we pulled out a third set of strategies which focused on trade nodes. Those places that are hubs for intermodal trade, ports, airports, as I mentioned, border crossings as well. This was important to pull these out because very often some of the model practices actually focused on the hub itself and were not intended to apply to, for example, trucking fleets that move throughout the greater metropolitan area. So the Clean Truck program at the ports of LA and Long Beach was a strategy for trucks that access the ports, not necessarily for trucks that move through the region. So we thought it was important to capture those with a separate category. Our assessment, and this sort of jumping ahead to the evaluation, was to look at the strategies, their effectiveness, both from a quantitative and qualitative perspective. So where the literature measured impacts in emissions reduction, optimization of routes, that sort of thing. And then qualitatively assessed their applicability in the US. As you can see, it's sort of a mixed bag. We have things like low emission zones, which have had high effectiveness in creating not only positive environmental benefits, but more efficient supply chains in Europe, are a much more difficult sell here because of the complex institutional structure that's required to adopt low emission zones. Despite a desire to implement one in New York, the New York State Assembly didn't approve it. So that's the type of analysis that we made. What I did want to do, though, is talk a little bit about four that did have do have likelihood, either demonstrated success or likelihood for success in the US context. As I mentioned, the strategies that get the most attention in Europe and Asia, such as zero-emission delivery vehicles or urban consolidation centers where you deconsolidate goods at the periphery of the metropolitan area and bring them into the city center on smaller vehicles, are problematic for reasons I'll talk about in the US context. Very often, they also don't give you the biggest bang for your buck. They're limited in scope, have a small market share. They may be too costly or require higher levels of regulation or subsidies that are not always readily available in the US context. As a result, in Europe, you get more focus on operations. In the US, you get more focus on infrastructure development and local policy and planning. The one example that's sort of the model from the US that is different, though, are those trade node strategies. We have best practices coming out of places like New York and Southern California that are being looked at as models across the world. It's a shame to tell you that there are all of these exciting freight-related activities using electric vehicles, alternative fuel vehicles, shuttles, and bikes, but unfortunately all of these pictures are from Europe. They depend upon, as I'll talk about briefly in a moment, public support for the development of deconsolidation centers within urban areas that then use bicycles, electric vehicles, smaller vehicles for distribution to commercial centers. There have been experiments using commuter rail in Paris, and sort of a variety of trucks, lockers, that sort of thing. We'll talk a little bit about what would make them work in that context, or possibly in the US context. The first set of strategies that does seem to work here, that we have some case studies in both Europe and in the US, are tied to labeling and certification programs. These are voluntary regulatory measures where the public sector negotiates with private industry to develop a set of voluntary targets that confer recognition or special benefits like flexible delivery hours. So in New York, the pilot test for off-peak deliveries allowed truckers who were using cleaner vehicles to park and unload in places that other vehicles and other trucks were not allowed to load or unload in, and at different hours. That's important because that priority access makes their supply chain more effective and more efficient and justifies the cost of retrofitting the vehicle fleet or purchasing new vehicles altogether. We've got examples of these green certification programs from places like London, from places like the Netherlands, but also from the US. There's the SmartWay program, which is a national program that truckers take part in to run cleaner fleets. We have the vessel speed reduction programs at the ports in California. There's a fairly low barrier to entry, which makes them attractive to industry, although the programs tend to be designed with larger shippers and beneficial cargo owners in mind, which is somewhat problematic for smaller goods movement players. There's also a question of local planning and policy, which is driving a lot of those alternative vehicles that you saw in the slide, 2 slides prior. This includes policies and guidelines for incorporating freight deliveries into new development. So these are changes to zoning codes, for example, or building codes that include requirements with regard to design for loading docks and for parking and loading standards. And very often it's a question of changing the dynamics over time as new developments are made. And it offers because that offers the opportunity to implement planning standards for on-site freight facilities. New York in the US, New York has pioneered a lot of this with loading and unloading requirements for commercial buildings. Barcelona has some very interesting both carrot and stick measures, so requirements for minimum storage size for bars and restaurants, which are big trip generators, and in small trips, so a lot of them. Barcelona also allows use of traffic lanes for pickup and delivery in the off-peak, which has been fairly effective. These are efficient measures in the long term, and because again better loading, unloading, and parking make the supply chain more efficient. You're more likely to have industry as a partner. Where it is difficult, these are costly measures to enforce, particularly with regard to traffic and parking, simply because the municipality or the local city or the regional planning organization really has no control over demand on the supply chain. And so shifting standards for where freight needs to be loaded and unloaded can be difficult to plan for. There are lots of unintended consequences as well. When you limit where trucks can park, you tend to get double parking where they can. And that causes significant conflicts between passenger and pedestrian traffic within urban areas. Truck fuel efficiency and emission standards are a big success, both in globally and in the US. They're effective because they address the entire commercial fleet. And it's an important problem to tackle because trucks and vans are major contributors of diesel particulates and NOx emissions in cities where the fleets are generally older. We've got numerous examples from as I said, Europe as well as Asia, but we also have a lot of homegrown measures, CARB's diesel particulate filter standards, EPA's 2011 truck CO2 emissions and fuel efficiency standards, the light truck cafe standards, and the LA and Long Beach Port's Clean Truck Program, which starting in 2006, and between 2006 and last year, overhauled essentially the entire fleet, the drayage fleet that services the ports. By port studies, so by 2009, and again the program started in 2006, the Clean Truck Program at the ports resulted in a 61% reduction in SOx, 48% reduction in NOx, and a 58% reduction in particulate matter and PM over that period. It's a success story. The alternative fuel vehicles are a bit more problematic for a couple of reasons. A lot of those programs that you saw from the European example required significant public sector support and subsidies in the way of deconsolidation or consolidation centers that allow the industry partner to focus on overhauling the fleet. There's a higher capital investment in operating costs for those vehicles. It requires, at least in the short term until the entire fleet is overhauled, for the company to manage a diverse fleet, which adds to their operating costs, which they don't like to do. Many of them still have limited range. There's a lack of infrastructure, although as we saw, there are plans to address that in a number of places. Lack of expert maintenance, and which is perhaps most significant for the trucking industry, investments in new vehicles really depend upon the ability to place a value on depreciation and their value in the secondary market, which is where a lot of trucks find themselves. And I think until that question is really addressed with the trucking industry, there's going to be resistance for alternative fuel vehicles. And then appointment and pricing strategies. This is a California model that's being looked at globally. This spreads the flow of truck traffic that passes through terminal gates, at least at maritime ports, across more hours of the day, in an attempt to reduce truck turn times and idling, which obviously has a negative impact on the environment because of diesel emissions. Somewhat problematic because it generates changes along the rest of the supply chain. If you change your hours of operation at the ports, it forces distribution centers, warehouses, other operators to respond accordingly. And retail establishments to focus on changing work schedules. But can't deny that the program in Southern California has been a success. This program, which set up a surcharge to move goods during the day as an incentive to move those goods in the evening or on the weekend, a program known as Pure Pass, more or less overnight managed to shift about 40% of the eligible cargo to the evening hours. Right? So it did have a significant impact there on the highways in and around the ports. There are other studies from Switzerland, Austria, and Germany. There's weight and distribution fees that are applied to the trucking industry. There's the Corton pricing in London. Truck pricing is a little bit more difficult than it is for passenger vehicles, simply because of the competitiveness of trucking with rail. There is significant resistance from the trucking industry to be part of congestion pricing programs because it puts them at a disadvantage relative to medium and long haul rail transport. That's another nut to crack. So as a result, it's worth, I think, looking at programs that manage freight movement as opposed to restricting freight movement. The programs that manage freight movement tend to be more successful regardless of the context, but we still have a lot of data research needs, particularly with local van movements and light-duty trucks. Heavy-duty trucks are usually incorporated into the metropolitan planning processes, light-duty trucks less so. So we need data on types of vehicles, operators, frequency of deliveries, particularly home deliveries, and actually the ability to track actual fleet movements. What are the costs of low emission zones on government as well as on logistics firms? We need some good pilot studies, and he talked about the benefits of actually having pilots. This is important as well as I think with regard to alternative fuels. And comprehensive best practice case studies evaluating existing policies and experiments, including certification schemes, like I said, which appear to be highly successful, truck access restrictions, and requirements for alternative fuels. And with that, I think I will end and we can move to questions. Thank you.